I've never
Okay.
been.
Sean, why don't we get started? I know you had, by the way, folks, this is Munir Mubashir. I lead marketing here at PKI Solutions. Sean, why don't you, we're going through the agenda. So why don't we continue because we're 5 minutes past the
Yeah.
hour
So
here.
I'm Sean Rayborn. I'm the Chief Technology Officer at PKI Solutions. And today we're going to talk about threat modeling basics, misconfigurations that can lead to signed backdoors and malicious code signing. We'll talk about how maliciously signed code can bypass security controls and threat detection. We'll talk about some best practices and hardening measures you can take to prevent some of these things from happening. And we also show how PKI Spotlight can monitor code signing, certificate creation, associated events to be notified of these threats when they really happen. So I'll move to the next slide. And this one's actually you, Munir. So
yeah. So some fun housekeeping. One of the things we have just started with this webinar is that we decided we'll give some t-shirts away, some other swag, PKI solution swag. So the way it works is we had a poll question on LinkedIn. We try to make it educational. Most of them come from Sean's head. We asked him, Sean, what's a good educational question? He gives us some ideas. We pop them on. So the first is please respond to the poll question and attend the webinar. So what we'll do is we'll randomly select 3 people from that group, folks who have responded to poll question and folks who have attended the webinar. We'll do this for this webinar as well, and then eventually we'll let folks know some names, other names you should be familiar with. Kelsey Johnson with a Q will be reaching out to the winners. And then we also have Carolyn Ballo, who's our customer client account relationship manager, another person you should be familiar with, and you'll see some emails from her as well. One last housekeeping, and I'll transfer it to Sean. One of the things that we aim to do is address the questions that show up on this webinar. It's like an SLA we have. We want to get to all of them if possible. And the second is that we maintain a webinar page. The webinar page will have the questions that were asked. We'll have the snippets, the key moments of this webinar. So something you can go back to post webinar and also share with folks and others as well. So little housekeeping, if you hear from, Kelsey and hear from Carolyn, it's most likely about sharing the post webinar page as well. So thank you again for joining. Sean, it's all yours. Let's start with that beautiful topic of threat modeling.
yes, sir. All right. So the next thing we talk about is threat modeling. So anybody in here, if you're not familiar with the concept of threat modeling, it's long story short, it's the exercise of trying to figure out how you would break your own environment, what all the risks that are identified are. You go through, you log them, you address them, remediate them, or suppress them. There are a few different tools out there to help you out with that. The screenshot up there is from the Microsoft threat modeling tool. And it's a very basic threat model. It's one that we've all seen a million times. It's the client going to the web service that's getting data at the database. It's a very, very basic threat model. And you can see, there are interactions. There's the request that's going over the internet into the data center onto the web service. The web service is getting data from a database, and then that data returns, and then ultimately we get a response from a client. It's a very standard threat model. When you go through and you create these threat models, especially if you use like a threat modeling tool, what happens is a bunch of threats get identified automatically. And a lot of these are, make sure that if you have a database that you're doing input validation, make sure that if you're sending data over the wire that it's encrypted, things like that. One thing about threat modeling, it's part of the standard, security development lifecycle. It's one of those things that you've got to continuously do. You got to continuously change and adapt to the emerging threats that are out there. And the biggest thing about threat modeling is that it all breaks down usually to about 3 different components, right? And that's a data store or a process. So that's these big icons in the middle. There's the pipe, which is the request response, and then there are boundaries. That's the internet boundary, and then the data center boundary. Those are the three things. And then anytime you're crossing a boundary or making an intersection point, new threats get introduced. And so, moving to the next part, if you look at each of these points, I just gave a couple examples. All along the way, there's an answer that's PKI related. Now, whether or not you choose to use PKI to address these items in your threat model is entirely up to you. But you look at the client going to the web service. Well, the client might have local data. It might be running an app. You might be running a user that's on there that's sensitive. There are mitigations that involve certificates that you could be signing the code on the client to make sure that it's coming from a good place, that the supply chain's good. If there's data local to the client, you can leverage PKI for disk encryption or for local encryption, and you can also leverage PKI for multi-factor authentication. Same thing with the wire. There's TLS to make sure that we have an encrypted channel. There, you could also use IPsec. There's mutual authentication, so we're actually going through and verifying the client on the way in. And then there's also if you knew that you were bare on the wire, you could do just flat file encryption and send that stuff over the wire. And you should have to have an answer to the key transport. And then on the back end, there's the same things. You want to protect the administrator connections. You have disk encryption for any sensitive data, and you signing code for any malicious stuff. So this is a very basic threat model. This is what a really advanced threat model looks like. And you can see there every single connection is TLS. Every single connection. So at least we know that we're going to be moving data over encrypted pipe. And why is this important? If we are using certificates to mitigate risks all across the threat model, where are these certificates coming from? Do we trust where the certificates come from? Do we know if we feel good about that? And that's where Spotlight comes in. I'm going to go ahead and move to my screen. Okay, so this is just a very basic Spotlight dashboard. And the main thing I wanted to show you guys is I've got just one CA in this environment. And if you drill into the CA, you go here, you go into the CA itself, configuration, you can see over here on the left-hand side, we have access control list that there's been some hardening done to the CA. Tier 0 certificate managers, we actually are participating in the ESAE system here. And we've really delegated authority to on the CA. We've done some hardening. We've gone through a hardening exercise, and this is important for later. I'm going to move to a client now. So this is our client, and on this client, we're going to try to run some PowerShell. So we have a PowerShell. It's just test.ps1. I'll show you what it looks like when we get done. But this is what we're going to try to do. And you notice that it didn't work. It's not digitally signed. You can't run the script. So, okay, well, let's do the regular bypass. The regular bypass would be set execution policy. And we'll just go unrestricted. Sure. That's a great idea. Oh, and we can't do it. There's something that's causing us not to be able to do that, to set that execution policy. So, if we go and we look at that file, you can see that it's just doing effectively a ping. right? There's nothing else there. It's very, very basic. And we're blocking that. Now, pretend as you will that this was malicious code. Now, a bad guy came in, we'd be blocking this, and this would be a protection mechanism that would block this code. Okay, we need to have it signed. So let's see what happens when we actually sign that file. So we're going to swap windows here to this guy, and I've already got it queued up to where we will sign that file, and then there was a signature there. We'll go ahead and clear our screen here to make it a lot easier for viewing. We're going to notepad that file again. And you can see now that there's a big giant signature block sitting right at the end of the file. The file has changed. So do we expect it to run? Yay, nay? Let's see. It says, do you want to run this software from this untrusted publisher? So you can see here, we've got the certificate stores, and we don't have anything in trusted publishers in that certificate store. Let's pretend, for instance, that I just, I'm a quick, irresponsible administrator, and I'm going to go ahead and just hit A. So yeah, we're always going to run it. And we'd run our ping, and everything runs, right? What exactly happens when you hit A there? Well, if you go into that certificate store and you refresh, you can see that there is now a code signing certificate in there. It's sitting in trusted publishers for the current user. It's we have a certificate in there, and that's the signer. So now we can run that code. So if the malicious code was signed, it would actually be able to run as long as it's in trusted publishers. And there's a couple of issues with that. So first and foremost being that how easy was that to accidentally leave that certificate in that store for that user? It was just a very simple slip. If you were running in the PowerShell IDE, you would actually get a pop-up box, and you'd be able to click on it, and that option is on the far right, and it would be very easy just to click on it and add it in. The other thing there's a lot of different ways that you can add. There's a lot of different ways that can be laid down. One of which is it can be laid down via policy. So I'm gonna go ahead and refresh that real quick in my not so subtle hidden window here that's refreshing group policy. And if we hit refresh here, on the trusted publishers, we now have code signing certificate in there. In fact, not only do we have one in there, we've got one in the local computer store as well, because it was assigned via group policy, right? We now trust this issuer all across the enterprise. So anybody that can modify group policy can enable this issue. And that, doesn't necessarily mean that you're enterprise admin or domain admin. There are a lot of ways to elevate to be able to apply group policy, change group policy without actually being, in those tier 0 groups. So you've really kind of reduced the profile of what somebody malicious could do. And then, there's the other fact is that you can actually hide this quite a bit. And when I say hide this, these certificate stores, so trusted publishers, if you go and you look at the certificate store view, and you go to view and then options, you can actually show the physical stores. And then we go back to trusted publishers. And you can see there's actually 3 different stores that are listed and enumerated here. You have registry, group policy, and local computer, right? And local computer is just kind of enumerating down from here. Group policy would be coming in if there was local user group policy, and then registry would be if we had this thing in the local registry, right? So that means if we used a script to lay down our REG file, we could get in there. If we used a policy to lay down a registry setting and a group policy object where there's a lot of registry settings being set, we can also have an issue there. A startup script, logon script that has an insertion point, we also can have an issue there. So there's several different ways that you can lay these things down to where they would be problematic. Here's the biggest kicker, though, is also in this folder with test.ps1 is we've got a file called invoke kimimets. And if we were to open that file up, well, look at that. That looks a little familiar to those of us in the community. And I've made a couple of changes to be able to get it onto the system. But the simple fact is this thing should have gotten caught by antivirus. It should have gotten caught by anti-malware. But what happened is we, at the very end, added a signature. And that signature, if we go to the file system, where that documents, so you go where it's at, you look at properties there, digital signatures, and look at there. We're now sitting in trusted publishers, right? Because it's the reasonably legit code signing certificate that we have there. If we go and we were to clear that block, that signature block, and just save, I use arrows because my mouse is acting up a bit. I opted for a very large signature, and this is the side effect of it, is that you have a very large block to clear. You delete that signature block, and then you save. And then if you look in here, you have a file here. It's sitting there. So let's try to. In fact, let's go ahead and see if we can sign that file. Yes, we can. So, it's very easy to go through, sign that, add that thing in there. And it's not wrong, but without the signature, if you go to Windows Defender, you can see that it was quite an excursion to get that on there without a signature. And I can show you settings. Here we go. We look at the protections, privacy and security. It's let's see here, where was it? Protection history, there we go. So you can see, initially, Defender caught this thing. We had to, go through, adjust some things. If it would have came in signed, we would have bypassed all this. Now, I wanted to make sure that I was considerate of the environment that I'm in. It's a server that I'm not there. I got permission to add this. I got permission to do all this. You can see, where this potentially is bad, right? And then if you go a step further, it gets even worse when you consider that, there are a lot of suites that will completely overlook a file if the signature is valid and it's sitting in trusted publishers, right? So, if we go through, we scrub that. I imagine once we scrub it, we go file save, and thread would run. I imagine it would go away. And we actually can go through and check that in a second, because it takes a couple of seconds. But eventually, I would expect I would expect the malware catcher to catch it. All right, it won't let us do if it's signed, so that's good. We go through, we add a signature. Eventually, we would, we'd be able to get on there. In a little bit, I imagine this is going to catch this though. So, what does that mean for us? So if you go and you look, so this is a full view of like what Spotlight looks like. You can see, this is a lab environment, but specific to the environment that we're talking about, this one server, you can see that there's a couple of things that aren't necessarily kosher. Number one, there's a certificate template that's snapped in called bad code signing. There are events that we can see. You can see, there was hardening that was done here. You can see when the hardening was done. But if you scroll down before the hardening, you can see, if you go all the way down, you go into some events, you can see, there was some bad stuff that happened. A certificate template, bad code signing was added in Active Directory. A certificate template, bad code signing was added to CA for issuance. And we would go through, we would let you guys know, hey, there's this bad stuff that's happening. In the newer versions of Spotlight, there are other things that we would potentially trigger when that happened. We would have probably a best practices alert set up for that. So let's go into the best practice sources. Takes for a second to load, and there would be an alert, a best practice alert here. If it was something that was identified as a threat, our new threat portal would actually catch it. Right now, our threat portal in our next release is going to be covering the Petit Podums threat, but in future releases, we'll be looking at very specific threat profiles. So there's a lot of different things that Spotlight can do to help in these situations. So you might ask, what caused this to be an issue? So I think there's a couple of different things that we can deduce from the CA itself. So I'm bringing the CA in. And so you can see right now, okay, in the certificate templates, we do have the bad code signing. That's a problem. If we actually look at the certificate template, we go right-click Manage. You can see that before the hardening was done, bad code signing. If you look at the security, you see, authenticate users, they have read, that's fine, we can read it. But then you can see that the username Sean has read and write on this template. Even more concerning, domain admins and enterprise admins have the default permissions of enroll. But the most important thing is that the user that made the duplication named Sean, that's currently not a member of any groups that are allowed to do anything from an enterprise perspective, has write on the template. So that means they can adjust certain settings on the template. If you look at on advanced, they're also the owner. So when you duplicate a certificate template, the person that duplicates it is listed as the owner, and they also have write permission. So if this exercise happened 5-10 years ago, before we implemented the hardening for the ESAE or for the tiering model, this user that's been the permissions have been perceivedly taken away. Those permissions are sitting in an ACE just buried somewhere. So that's one issue, right? Potentially. There's another potential issue. If you go to, and this one's probably the more common issue. If you go to so suppose we did like a network scan and we're looking for a very specific file type. That file type would be a PFX. So if we go and we look at that, oh, look, we've got a PFX, certificate import wizard. Oh, what's this? We have current user. Where do we want to put it? I don't know. We'll just put it local. And then we got password. Let's go ahead and guess what the password is, right? That was easy. And looky there, if we go to the trusted root certification authorities, or not trusted root, current user, now we've got that code signing cert, and we've got the private key. So what causes us to be in this situation, right? A, putting it on the net log on share, that would be bad. B, let's just say the developers, they put on a share in Teams, or they send in an email or something like that. I mean, it's one of those things that a lot of dev shops, they'll do that. If they need to have a key for signing, they're just going to spread it around. It's a trivial exercise to sign stuff, and you don't necessarily want that to circulate. You want maybe to circulate a test certificate, but not necessarily the one that you're using for your enterprise application. Ideally, you'll have those things stored, in an online vault, like an Azure Key Vault, or like an online HSM, or on a local HSM instead of in the local stores. And you don't want that stuff floating around in email or on a share or something like that. So why is this important? If you look at the news in the last few weeks, and then just in general, there's a lot of threat actors that are using this factor. Most recently there was a Windows hardware compatibility certificate that was used to sign a malicious driver. In the past, there were other code signing certificates that were used, and if you sign code and it's signed by a legitimate certificate, or even worse, if it's signed by an EV, an extended validation certificate, it has the ability to bypass almost every single control you have out there, whether it's a group policy control, a software restriction control, application whitelisting, anti-malware, threat detection software. You name it. If there's a legitimate signature on it, we're going to let it run. If you go a step further, this is the Windows only problem, right? You could still jailbreak other systems and put bad code in there, right? You can jailbreak iOS, you can jailbreak Android, you can insert, legitimate but bad certificates, sign stuff, get it running, and go on. You might even be able to fool the vendors into thinking that those things are legitimate. So I'm going to stop for a second. I'm going to look at the Q&A real quick, just because I want to make sure that we're addressing questions. I don't see any in the Q&A real quick. Let me make sure that we...
Yeah, it would be under the published one, Sean. So as we look at new, answered, published.
Oh, I got you. Okay. So I did see a question, but I want to make sure I get it. It must have gotten deleted. So
yeah, so I don't know if I'll read it out. So one of the first question was from Lee here, Newbecker, and this was about the what is the platform key that should be on a Microsoft Surface Pro 9. The comment is there are conflicting PKI documents floating around on the web that have different page counts and keys, but the same unique DocuSign envelope ID? That's a question that's from Lee there on what's the platform key that should be on a Microsoft Surface Pro 9? I know not related to the topic, but I think it's a question.
Yeah, that's a question I'm gonna have to take offline because I don't really necessarily understand the context of the question. So definitely a thing to take offline. I think in light of some of the things that have been in the news lately and things like that, I think there's a lot of scrutiny on a lot of folks' co-signing practices, and a lot of times if you have attestation documents that are saying that, hey, we can trust these CAs, they're third party, that have come in from third party places. If the signatures are broken on those documents, it lends itself to skepticism. And I think that's one of those things that's probably going on there, but I definitely would have to investigate.
Okay. Let's just take this question also from Ivy here, and it's in the chat. It's in the chat if you can see it. The question was, what happens if code is signed and you find out that the code is compromised? If the
that's a very good question. So if the code, the code is signed and you find out the code is compromised, if it's a situation where you control the CA, you can revoke the certificate, and also you can push it into untrusted publishers, which explicitly denies that co-signing certificate from running. The downside of that is that if you have published anything else with that co-signing certificate, you're going to have to go through and republish it, right? Because if you put something into untrusted publishers, it renders it useless. Other things that you can do is if you know that there's a binary that's not kosher, you can add it into application whitelisting as an explicitly blacklisted item. So I mean, there are several things that you can potentially do, but the danger here is that if you're already using a ton of code using that certificate, you're going to have to reissue all of it, and you have to redeploy all of it, right? So it's a very touchy thing. And typically, legitimate certificates that are used maliciously, they've already signed things, and you have to go through, you have to replace them. If the code signing certificate is expired, out of date, but the application is still needed, is there a way to validate its certificate can still be trusted? Yes. So there's a process called timestamping, and I can actually come back to our demonstration server. So let me move over to that real quick while I do that. It's taking a second.
Okay. Sean, you got to go to your screen. Just make sure you're on the screen.
Yeah, I got it. Okay. It's frozen. I have to change.
Okay, all right. Just making sure. Okay, we see it.
Now you see it? Okay.
Yep.
So if you go and you look at the file that we added the signature to, if you go properties on this, you look at digital signatures, you can see that there's a signature there. We'll hit details. Sorry for how small the window is here. I tried to increase the size on everything, and it didn't help. So if you look on this is actually a representation of that certificate. You can also see there's a counter signature, and this is what's called a timestamp. And the timestamp, I basically reached out to DigiCert's timestamping server and grabbed a signed timestamp from DigiCert, and that basically shows that the code was signed at the time that it was, at the time that, or the code was there's a timestamp that matches when we signed the code with the certificate, and that's how that gets done. If you look at the PowerShell command that we ran to do that, you can see that we added minus timestamp server, and then timestamp.digicert.com to the path, and basically you're allowing it to still run after the certificate expires. There was one other question that had popped in, I thought, and maybe it was just
yes, there is. We're just these are getting moved to the published one. So there was one where what would you recommend? There was one where, I don't know if since you're there, where was about being able to look at your mind showing what is in your trusted root certificate of the cert manager. If you're there, Sean, maybe showing what's in the trusted root certificate of the root cert manager. That's something Lee wanted to see. But there was also a question again on what would be your recommendation? This is for detecting code signing abuse, especially anything endpoint related.
Yeah. So so to repeat your question, it was twofold. Number one, what's in the trusted root certificate store? And I can show that real quick, right? And that's for the computer. If you look at the trusted root store, it's a fairly standard store, except I've got a root that's coming in from my environment, right? That root is actually, if you go to intermediates certificates, that root signs the issuing CA that eventually signed the certificate that was the code signing certificate, which I don't have on the system. Actually, I do have on the system because I added it in there. So if you look at the cert path, you can see that chained up to the root. Other than that, this is a pretty vanilla Windows build that I pulled down from Azure.
Okay.
So that was the first question. Second question was on endpoints. How can we detect misuse of code signing, legitimate code signing certificates? So that's the bad news. It's once the damage is done, the damage is done, right? In a lot of systems, a lot of solutions are going to see that malware that's being signed by a legitimate certificate as being legitimate, right? Because you're lending the trust to that, because we're lending the trust to the certificate authority, and that lends that to the issuing certificate authority, and that lends that to the code signing authority. Effectively, that certificate represents our organization. And if you trust that, then you inherently trust everything that comes from that. So if you are signing good code with it, and the installers trust that chain, then they're going to allow it to run. Any other certificates that are sitting in here just because they're in here? I didn't strip these stores. I left them pretty blank. I did see a question in there, why are some old certificates and stuff in there? The only certificates added to the store is mine. The red, it's a Windows build that I added in, I think it was yesterday. So another question I saw was, do we use certificate, do we use different certificates to sign different code? I think the answer to that is probably yes. And I would say what I would do is I would have, a test prod QA tier set up where you would have a test certificate that could freely roam, but also have maybe a shorter lifetime or, a protection mechanism around it to make it to where, it's not good for very long. It's not good for production systems. The other thing that you can do is just make sure that you're always using an HSM or some sort of mechanism where that private key never leaves that system, and that you're using some sort of a mechanism that's going to pry that key out for signing purposes in a fashion to where that private key never hits the wire and it can never be circulated and can never be exported. So this is just one example, and I've got a lot. I mean, going to that CA, there's we could, if we look at misconfigured web server template, it's not snapped in, but if you look at the security, you have a very similar situation. User Sean, if you look at advanced permissions, that person is the owner. That's not a user that should be elevated from a domain perspective, but they've got edit. This is a certificate template that has supply in the request. It also has an issuance requirement without a certificate manager approval. And if you can put whatever you want in the subject name and you don't need to have any sort of approval, you can actually use the MMC if you have enroll permission to set that certificate. In this circumstance, it would be a TLS certificate, to have a subject name to be whatever you wanted it to be. And that allows you to set up man in the middle. It allows you to do spoofing. You could set up an appliance that does man in the middle to outside websites, and do some password shimming, and you could do some keystroke logging. There's a lot of different things that you could do with misconfigured servers, and in a lot of those circumstances, we're going through and catching these things in Spotlight as they happen, right? And so in these specific circumstances, you go through the events and you can see, hey, we had, if you scroll into it's the previous events here. I've had so many things happen since I built this thing that I drowned my events out that I had. But yeah, you see a misconfigured web server is added to CA for issuance. You have, it's the template's added in Active Directory, and you can see some of the information. This is on the current release version of Spotlight. If we were to look at a newer version, and, it's not for this. It's not for the CA. However, if you look at the events here, you can see some things that are a little bit more granular about some of these. So you can see, okay, certificate template was changed in Active Directory. This is a newer feature that we can do, and you can see, okay, this template was changed. And if you go to that Active Directory forest, so this one was this one's contoso.com. Takes a second to get there. If you go into certificate templates, you can see the templates that are in there. You say, oh, okay, custom web servers, one that you see there. You can see the ones that are in use. And then on the right-hand side, or let's look at one that, do we have a bad one or a misconfigured one in here somewhere? Let's look at web server v2 just out of curiosity. You have view template, and these things enumerate. You can see what these things are. So subject source built from the directory. If you were doing enrollee supply subject, this would be different. And then you would see some of the other, you'd be able to see some of the other permissions there. If it is defined as a best practice to not have certificate templates, if you have a best practice defined, to not have certificate templates with enrollee supply subject and and the certificate and the manager not there, it's going to show up, right? This is one, that this is what that looks like, and that's how that fires, right? Certificate template is configured to accept subject from request. This does not require CA manager approval. This is going to be our next release, and this is pretty slick. Any other questions?
Sean, we have other
DevSecOps. What would be best? A different code signing for each pod. What would be the best practice? So, because it's new, I think the best practices for DevSecOps are still being defined, right? I think the biggest thing is that if you have an HSM, if you have HSMs involved in the process, you mitigate a lot of that risk. The floating PFX file is a real problem in development shops. It's one of those things that's very understated. It's one of those things that if we had like I've often thought about having, one idea I threw out was having like a snitch portal, right? Like almost like a compliance I guess you'd be self-reporting. So anytime that you'd have a floating PFX or self-signed code signing certificate or, something that's just not kosher, you could upload it and, say, hey, there's not really any good answer to the most right way to do it other than making sure that you're using an HSM, whether it's a cloud HSM or a local, local HSM to do the signing for the production code. And then if you're using an EV, there's a very good chance they're not going to let you have it unless it has an HSM. However, HSMs are still vulnerable, right? If you lose the quorum or if you have, there's still some things, very advanced attacks that can affect those. But I mean, we're talking about proximity, and you'd have to physically be there, and a lot of those things are mitigated by walls and fences and gates and guards.
Sean, when we're at it, let's just take this one question from someone. It's about, about creating an internal PKI for signing code as opposed to using an external, certificate, using your internal PKI to sign scripts, codes, for example.
Right.
And what's your opinion about that? I know others have responded that they already do it in-house today to package their applications and part of the packaging process. What do you see? What's your thought there?
Yeah, so for internal stuff, for internal stuff that that it's not going to go out to the outside world, that it's an internal app. You have to be very careful about using a certificate authority and really a certificate that you're going to be doing a broad stroke trust on everything for. Because it's a broad stroke trust that you're delegating to anybody, you need to make sure that those certificates are protected. That we're not in a situation where we're floating PFXs around. If you are in a situation where you have to absolutely issue a soft certificate, when I say a soft certificate, it's a certificate that's stored in software rather than in a hardware device. You want to try to put as many risk mitigations out there as possible, and have the easy button for undoing everything ready to go at your disposal. And that's a lot of different things, right? There are a lot of different enforcement mechanisms for signing scripts. And when I say signing scripts, they're signing scripts, they're signing code, they're signing macros in Word. There's a lot of Word or Excel or things like that. There's a lot of different enforcement mechanisms out there. There's also application whitelisting. There's the lesser known software, SAFER, software restriction policies. There's things like that. One thing that you can do is there's certificate panning. You can make sure that the certificate the private key originates from a TPM protected device, which kind of limits the signing to a single system, but it mitigates some of that risk. Now, if you have local administrative access, you can still pry a signature off of that TPM, right? So there's still some hardening that you would need to do that within out an HSM. But the ultimate answer is to have an HSM that is distinct and separate from all the different processes, and to have proper escrow of cards, tokens, whatever you're using to activate that HSM.
Awesome. I know we have 5 minutes, and we should have created a poll, but I'm gonna ad hoc create a question for our audience. How many of you are actively code signing your PowerShell scripts today? Is that has that come in as a mandate from your security groups? We would appreciate if you could just kind of respond to yes. Code signing. PowerShell code signing is becoming more prevalent. No, it's not. If you could, put that on the chat, we're curious, because that's something, if you know Jake from PKI Solutions, he brought that up, and he said this is something that we're seeing more of in certain environments. We're curious to see if you see more adherence to signing your PowerShell scripts before they're deployed and run on your servers and other devices. So, question: are you deploying more of signed PowerShell scripts in your environment? Love to see some responses to that in the chat. Okay, so as we're doing that, as we're getting the responses in, we have 4 minutes, and I wanted to briefly talk about the next webinars.
Yeah, absolutely.
Is that
Let me
okay?
move this forward.
I know you want to get to as many questions. We'll follow up with others. Of course, the first key takeaway, we're seeing this over and over again. And I'm, as you said, I'm Munir Mubashir. I lead the marketing team, and I'm relatively new to the PKI world, the cybersecurity world. I go back to IT a long time, and one of the things that was made awareable to us is and when I joined, Michael Bruno, who you'll hear from on the next webinar, is a PKI software developer, sent me this certified pre-owned document. I didn't know what to make out of it, but the most important thing I want to share there is that the need to secure is high, and we're here. Sean, Mark, Jake. Even folks you might not be aware of, like Michael Bruno, who is part of the software development staff, Vadams, the author of PSPKI tool set. So all of this is being worked on to do things, right? To provide the answer, as Sean talked about early on. How do we provide an answer to hardening, to cyber, to cryptography, identity access, where PKI is the best answer? And while we're addressing it, how do we make sure that we configure, set up, and maintain PKIs? So that continues to be an important theme for us. And we're here, right, for any consultation, any conversations, the team. But more importantly, as we look at the sets of webinars, we have 2 webinars coming up next month. The first is PKI Spotlight, What's New? And on this, Nick Sirikubut and Michael Bruno will cover the latest enhancements, and this covers best practices, covers checking for petite podum vulnerabilities, all the new stuff, right? That's Feb 7th. And then again, an important topic that's top of mind for a lot of you, and it came from some of the earlier questions on the webinar and our engagements. It's this whole certificate-based authentication changes associated with this, the knowledge-based upgrade, as Microsoft said. It has implications. There's a deadline, there's an impact, there's an action. It, as I said, came up in previous webinar questions as well. We will specifically cover that topic, and that's on Feb 15th. So I just want to give a heads up on both, because I know the second one is definitely top of mind for a lot of folks as they're dealing with these enforcement changes coming in from Microsoft. So that's our next webinar. Sean, do you have anything else to say before we kind of wrap up here?
No. So we have the next 2 webinars, and I also, so I'm going to go back one slide. And if you care about your misconfigurations, don't want that to be your reason for the next attack, let us know. Sean at PKIsolutions.com is my email. Send me some email. If you want to schedule a demo of Spotlight, or you want to talk about some of our other professional service offerings where we can, help you, modernize your PKI, or we can help you help train your folks if you feel like your organization is behind in knowledge. Contact Carolyn. It's CAROLYN at PKIsolutions.com, and let us know. Give us a proverbial call or send us an email.
Excellent. With that, we will wrap up this month's webinar. Thank you again for everyone taking the time to join us. It's always fun. And as I said, we will have a webinar page dedicated to this, and we'll post your questions and the responses to your questions on that page. So keep an eye on for that. Thanks again, and hope to see you all on our next webinar.